So I just wanted to talk to you about fractions and how they work and represent a value. So if I start with something that we're all familiar with, and I think that might be a birthday cake, and when we have a birthday, if one other person comes, then I would cut the cake in half. We would both get overfed, and each part I would call a half. That means that I've had one thing and I have divided it into two parts. So that's two parts there, and I've got my one whole. Okay, so I've got one whole divided into two parts. And sometimes that whole is a cake, and sometimes that whole is a certain measurement, and sometimes that whole is a distance, say a kilometre. So it doesn't matter what the whole is, but the thing is that this tells me that that whole has been split into two equal parts. So each of these are a half. And then also, and then again this will be familiar, so if I had a shape like this or a distance like that and I divided it into 4, then you could tell me that each of those is one of the 4 parts, and that if I wanted to end up again with a whole, then what I'd need to do is I could go, well, if I had 1/4, so that's this bit here, and I multiplied it by 4, then I would get 1. So I can see here I have 1/4, another quarter, another quarter, and another quarter. So that's 1, 2, 3, 4 quarters. And when I multiply it by 4, one of those by 4, I get a whole. So 1/4 times 4 equals 1. And so this is worth remembering in the maths problem that you're trying to do, because I'm pretty sure that you have, if I want to multiply something to get a whole, then if I look at the relationship between the denominator and the what I'm multiplying it by, then I can create a whole. So I'm going to shift the board up. I might wipe this away quick. Wobbles a bit when I do that. Go shift, 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 shift. That might be enough. So just as an example, if I wanted to work out what 1/6 times 3 would be, well, then I go, okay, well, I need to split up a whole, so I take my whole. So this is my thinking here. I've got a whole, and I'm going to split it up into 6 equal parts. So I have to draw 5 lines. 1, 2, 3, 4, 5. And now I want to know, I now know that this one here, this here is 1/6. Yep. So that's 1/6. And I can go, well, I want 3 lots of 1/6. So then I could go, okay, so that's 3 lots of 1/6. So that's 2, there's another 6th and another 6th. Yep. So that's making sense. Now, the thing is that I can now see that that's 1/6 there and another 6th there. I can see that that has made how much of the whole? Well, I could call that 3/6, couldn't I? But let's have a look at this. Let's see what happens if I move this up just a little bit more. I can now look at this in a whole other way, and maths is a lot to do with seeing in different ways. It helps us to calculate. So I've got 3/6 here. So I'll just shade them individually so that you can see them, so how they relate to the one above. 3/6. Yep. And if I look at this, I'm just going to remind myself that that is 3/6. Yeah. If I look at this, I can see that that's 3/6. I can see them relating to the ones above. Yeah. But also, I can see too that it's the same as a half. Because if I take these lines away, I can see that I've actually shaded in a whole half. So 3/6 is the same as a half. Now if I wanted to make a half into a whole, well, we go back to the beginning, don't we? And we have a think about what I told you at the start, which was that if I wanted to make a half into a whole, then I have my whole here, and I've got two halves. There's my half, so that's my half there. I'm hoping you can see that. Maybe I'll draw it down the bottom, and I know you can. So that's my half there. And then if I want to make that into a whole, I need two of them. So I'm going to go a half times 2 equals 1. And I could draw that real quick here. Here's my half. There's my other half. And that there makes my whole shape shaded in. So it's this kind of thinking that is going to help you with the maths problem that's at the bottom. Okay. One last thing on that maths problem. When you are doing the maths to try and get it correct, which you will be, you notice that there is a table that's like this. Yep, I have put some numbers in it. I can't remember what they are. You need to delete those numbers, okay? And what you need to do is you need to make sure that every number that's in there, or every value that's in there, when they're multiplied as a row, yep, or as a column, always equal 1. So if I had 2 times 1, that would give me 2. And then if I times 2 by a half, then I know that I'm going to end up with 1, because a half, 2 times a half is the same as a half times 2. So I'll pull that down so you can see that. 2 times a half is the same as a half times 2, and a half times 2 equals 1. So now I know that going across here, that would equal 1. So that's cool. Then what I need to try and do is keep rearranging it, and so that in every direction, every time I multiply whatever's in a row, multiply that one. So I suppose one way to think about it is that in between each row is I've got a multiply and a multiply there. I've got a multiply symbol there and a multiply symbol there. So as I go across, I multiply, and as I go down, I multiply. So between each one, I have to multiply, and then my answers would be here. So that would be 1, wouldn't it? 2 times 1 times half equals 1. Yep. Cool. As it's Thursday, I want to give you a clue, because this will help you to solve it. I'm going to tell you now that, and we'll put a little multipliers in there. That helps. That 1 goes here. 1 goes there. Okay. Then you want to have a look at the other numbers, so that everything is equal when you come down here, and when you come down here, and when you come down here, that everything is equal to 1. Okay, it should turn out that actually diagonally it's true as well, but that's another thing. Cool. Good luck.